To draw this direction field is a much more laborious task. So in the previous two examples, we had negative bunch of y stuff or just a bunch of x stuff, so we could kind of do a column or a row and just copy the slope field over and over again. But in here, y prime is dependent on both the x value and the y value. So to actually calculate the slope at every point, we have to calculate it for every point. We can't make a shortcut. And so, right, if you wanted to actually do this, you'd have x, you would have y. I'm not going to draw out a whole grid, but let's see. -3, -2, -1, 0, 1, 2, 3, -3, -2, -1, 0, 1, 2, 3. You'd actually have to do it at every single point. You'd have to do a lot of calculations. Right, every single one here. And everything in the middle. I think I have the right number of dots. So I'm not going to do that because it's rather boring, but we can get some of them filled out at least. So in here, if we have -2xy, if x is 0, it doesn't matter what y is, y prime is always 0, because 0 times whatever is still 0. So I can say that when x is 0, all of these numbers are 0. And I can also say that when y is 0, it doesn't matter what x is, y prime is always 0. 0, 0, 0, 0. So I can draw on these lines without doing a lot of computations. Then the next thing is, okay, well, I don't want to calculate all these, but the sign ends up being the same. So if we're over here, this is when x is positive and y is positive, we end up with -2 times a positive number times a positive number. It's always going to be negative. So the slopes are all going down in this quadrant. When x is negative and y is positive in this quadrant, we get a -2 times a negative x times a positive y, negative times negative times positive. All the slopes are positive. In this quadrant, when x is positive and y is negative, negative times positive times negative, it always comes out positive. When x and y are both negative, we get negative times negative times negative. That ends up being negative overall. If you did some more lines, you might be able to figure out some more things, but I'll give you a shortcut here. So we know we're going to start here, and since it's going down on this side and up on this side, it has to look something like that. But eventually we're going to go down, we have to get back to 0, so it should do something like that. And it ends up being symmetrical. If x is, you flip x to negative x, it ends up flipping the whole thing. And so it ends up being a bunch of hills, just repeated over and over again. And same thing on the bottom, it's just an upside down hill. And then if you're actually, really talented and could draw lines with a really accurate slope and follow them correctly, you'd end up with something that looked like that. And so there are all the hills. And again, I highly recommend Ariel Barton's from the University of Arkansas's tool that I linked to on the webpage for this. It can actually draw the slope field for you, and if you click on it, it'll draw some of the integral curves, which the integral curves are these things, the actual solutions. And that's it. So usually it's either pretty easy or it's really difficult, and then even when it's a slightly less work, it's hard to plot all the lines correctly. But it does give you some information.